Okay, the first sessions for the afternoon's class, I will just explain first what we are going to have, because we are going to have all the exam will be online, and we are using a one kind of platform. We call the Flexi Quiz platform. Basically, you just need to click the link, follow the instruction, but there will be some sort of details that you need to be taken care of. Okay, so every time we will have an exam, uh, whenever you open the platform, I think if you are using uh, Mac, okay, or I think an iPad, I think you'll be fine in some way. But if you are using a Windows laptop, uh, please use the uh, let's say the private browser. Okay, if you are using maybe Chrome, your browser, you can uh, using the incognito tab, okay, or incognito mode. Okay, because sometimes uh, because of your case files, okay, the case files behind your browser, if you are not really optimized, then the platform cannot really give you clear picture of your screen, and when you type in your answer, sometimes it's not recognized your writing. So my suggestions: use private browser or incognito mode. Okay, that will be uh, the general case for our online exam. So we are going to use the Flexi quiz. Okay, there are several mode or not mode, several type of questions. Usually, what I would like to write is sometimes we have the match descriptions. I think no problem with this. It's still just click and find which one is your answers. The other one is single option choice for multiple choice. This is also okay. You just click and no problem at all. The the other the other type of question that we are usually have is fill in the blank. For fill in the blank, you need to be careful of what the instructions going to give you. If you need just to write your letters, just write the letters A, B, C, D, or Y, N for yes and no, or T, F, or T, true or false. Or if you need to write a number, then you need to write a number. Okay? And there will be some way to write your numbers. Okay. So for example, to write a number, there will be some sort of details that I need to give you to give some explanations to write numbers. Usually the numbers will have the, for example, fraction. Then you can write like this or etc. Okay. If you need to write an equation, I think a few questions will need you to write an equation. You can write as best as you can in the system. I will check your paper later on when you submit through uh, the Google Drive. Okay, I will give you later the Google Drive. So to write the equation, for example, if you have y equal c e with 3x plus, let's say this is c, the constant. Okay, and you can write with another constant, for example, d e negative x. For example, you write this. C and D is a constant. Okay. You can write as in your typing is Y, C, E, and then with a power like that using the usually if you're using a regular keyboards it's your in your 6, okay, in your 6 you press shift and 6 and this will be your symbols, okay, and then 3x usually to make distinctions, because if you just write this maybe it will be like this, right? So probably better using a bracket. Okay, so a bracket. You can write bracket using this, or bracket with the this bracket also okay. Just to give clear structure, and then D, E, and then with power. Okay, if it is include, like for example y sine 2x, for example, like that, you can write sine and then you can use bracket like this, 2x, and close the bracket. Okay. You can use this kind of bracket or just bracket with just normal bracket like that. It's okay. If you are familiar with coding writing, okay, you can write through that type of writing also. But for me, the simple one is also okay. Okay, just to note the notes. Okay, there will be some, I think one or two questions that need to write equation, and also for other exams, you need to keep in mind we are using the same platform. But don't worry if you write a typo in your answer in your system. I will check the paper. Okay, so you need to still need to also send your PDF paper. So after you go through all the calculations, please scan your calculation and send to some specific folders in Google Drive. I will give later on. Okay, I think that's more or less about the quiz. So the quiz will be having some duration. Okay, and usually we have at least 2 pages. Okay, the first page is I think more on introductory questions. Okay, not really that complicated. The second one usually more advanced questions. Okay, and whenever you submit, so you go page 1 and you go page 2. When you want to go back to page 1, you cannot go back. Okay, so everything page 1. Okay, submit, and then page 2. Okay. Anyway, the quiz itself, you may work the quiz. For the quiz, let me write here. The quiz can be worked in on any days in the period. Okay. For example, I will give you 4 days, at least 4 to 5 days for the quiz. Okay. Either it's tonight or next tomorrow morning. So you will have Thursday, Friday, Saturday, Sunday. So you still you at least have 4 days. At least have 4 days to work on. You can choose which day you are going to work. Okay. And please keep in mind, although I didn't mention whether you can do with groups or just take individual tests. My suggestion is to take this as individual tests. Okay, just to check your understanding. Okay? So please work on the quiz during the periods. If you miss out the quiz, they will be very difficult for make up. If we have to make up one, if you fail to not fail, you miss out the quiz. I will not be able to prepare another one because of the time limit. So I think you need to keep in mind, okay, every quiz and homework, try to be on time. Okay. Okay, I think that's just an introduction for some exams that we might have in the future. Okay. So quiz for this week and probably midterm next week. Okay. But for midterm, I think uh, next Friday, not this Friday, next Friday probably. Okay, because I think I will just focus for this week, finishing all the chapter for the higher differential equations, and if we have Laplace, we go to Laplace a little bit. The midterm, let me tell you maybe now. The midterm will be let me go through here. Midterm will include the introduction, the first order differential equation, and the higher order differential equation. So just these three. Okay, I think should be enough. Okay, and uh, although in our lecture I didn't give you some models, but if I give you like a simple models, I hope you understand. Okay, I hope you understand. A few questions maybe about them. Simple models that can be solved through first differential equation, first order. Okay. For higher order, I will not give any models. I think just enough for just only the method. Okay, that is the midterm. Okay, this will be probably on maybe 22nd, probably. So the structure is this week finishing the higher order, and if we have exercise, we will have exercise within this week. Next week, maybe we are going to have Laplace, okay? And for Laplace, there will be another session for quiz after the midterm, and then another week after that, on August 1st or August 3rd, we will have a final exam, finals. And probably the last part of our lecture, the vector calculus, maybe we can cut some part and then we can just have the most important one. Okay. Okay. Any questions first? For quiz, I think it's okay. Everyone finds okay for the time? And I think for Laplace also some part I will skip. Some part we will skip. Okay, I think we can continue. Okay, we can continue, and we will continue from the undetermined coefficient. Okay. Let me just give you more examples, okay, and then we can have some conclusions. Okay, another example. Solve the y double prime. Okay, now we have this. Of course, you need to remember, now we are solving the non-homogeneous one, right? Then we need to find first, the first step, homogeneous, right? Homogeneous. So find this homogeneous. We can solve by taking the, so step 1, homogeneous solution. So we can write the equations in terms of the homogeneous. And we know from here, we can say that this can be written as this. And we know that okay, and we can write okay, and then we can write the general solution for the homogeneous one is C1E 3x plus C2E negative x. Okay, so this is the first step, right? Okay. The second step, we are going to solve whether this is having a particular solutions or not. Okay. And we're going to see that if we write, or if we are looking at the right side, we see that the 4x minus 5 is a linear equation, right? Linear polynomial is, or we can just call polynomials, right? Or linear polynomials. And this other part is exponent, okay? So we might have two forms, okay? The polynomials and the exponent. So we might have the predictions for the yp. We will have yp1 plus yp2 from this the particular solutions. Okay, probably we will have. So we can guess. Okay, we can guess. So we will have two kind of yp. So yp1, we will guess yp1 as a polynomial that is ax plus b. Okay, and yp2 is having cx e to x plus e, c and e is constant, and exponent to x. Okay. Now, if you remember why I'm writing like this is actually similar to superpositions principle that we have for non-homogeneous equations. Okay. So this is also called the superpositions. Let me just write superpositions principle for non-homogeneous. Okay. So why we need to have two constant e, c, and e from the exponent? Because if we think, okay, if we think clearly, the product of xe to x, okay, if we take the derivatives of this, if we take the derivatives, it will result in 2x e2x plus e2x, right? So we have these two products that it will be a similar form. So probably that is the way that we are going to write in our solution. Okay. Okay. Let's say we have this two yp. So our total yp that we predict that it's going to be our solutions is ax plus b plus cx e2x plus e exponent 2x. Okay. Now what's happened? Now we check. Okay. So every time we suggest our yp, we going back checking whether this is going to be possible or not, and then equaling both the left and right side. Okay. So first, yp double prime, not yp double prime, yp prime first. So a plus, I will write c, and then this x e to x, 2x e to x plus e to x, that's for c, plus this is just 2. Okay, like that. Let me solve this first. So a plus 2c x e to x plus oh, let me write 2c. Oh, let me just write one by one. 2e e to x plus e to x. Okay, we can also group this a little bit. Okay, now y b double prime. So let me write this as first equations. The second equations, you differentiate one more time to see this x e to x getting the same 2x e to x plus e to x plus 2e to x, 2e plus 1, right? Okay, now we can rearrange this. So 4c x e to x plus 2c e to x plus 4e to x plus 2e to x. Okay, it seems a little bit confusing here. Let me just take the yp double prime. I think we can move a little bit to the left. Okay, this is also going to the left. Okay, I think e to the x to the 2x is 2c plus 4e plus 2 plus 4cx e to the x. Okay, now we input all this. when we write this is 2yp prime, okay, and then multiply this one, so 2a plus 4cx e2x plus e2x 2e plus 1. And then let me just minus this. Okay, can we get some number? Oh, I think better just to expand this, right? Not in the bracket. So 4cx e2x plus 2c e2x plus 4e e2x plus 2e2x, and this is also similar. So 2e e2x plus e2x. Okay. Okay, we try one by one. So yp double prime minus 2yp prime is, I think it's the same, right? We can cancel. This can be cancelled like that, and this is also can be cancelled. So this is 2. Okay, we can write 2a plus 2, sorry, should be negative 2a. Okay, that's the first, and then we need to compute this with minus 3y, so 3y. So 3yp is, yp is 3ax, right? 3ax plus b plus cx e2x, or 3b, sorry, 3b, 3cx plus 3e e2x, and then minus. Okay, so okay, I think if you prefer like subtractions, if you have this differential equation, I think this way easy to follow, right? Rather than writing horizontally to the right will be very confusing. So writing here, negative 3ax, negative 2a, right? Then let me just make some connections with to make sure it's understandable. This x should be like that. It should be also like that. Okay. I think we can write all the constant x. Okay. See. Okay, I think we can write e2x. Okay. This will be 2c plus 2e, right? And then minus 3e. So minus e. Okay, this will be minus e. Or is it correct? Minus 3e. Let me check. Minus 3c. Okay, maybe we could write the c first. minus 3cx e to x, okay, plus 2c wait. Uh, I think I have some mistake here. Oh, I have mistake here. Okay. All right, this mistake. I think this is the mistake. I think this is the mistake. Okay, let me just erase this. Should be C e to the x. Not the problem here, but the problem is on this one. Okay. For e to x plus 2c e to x. Okay, that's why this is going to be wrong. Let me write 4 and 2c. 2ce. This will be wrong. But anyway, I will give you detail on this method, okay? I will check later. But the rest, okay, the results for what we have here, they're supposed to be plus 2c minus 3e and then e to the x. Okay? This is the final calculation of the when we are going to have this prediction to yp. Let me just copy it first, and later after the class I will give you the correct one. Okay. Now we can equaling both sides. 4x minus 5 plus 6x e to x. Okay. Now we are having this is sorry. Okay. Now we are having negative 3a is equal 4. So we have a is negative 4 over 3. And we have negative 2a, negative 3b. Alright. We will have this is negative 5. And we will have negative 3c is equal 6. And 2c minus 3e is equal 0. Okay, so c we got negative 2. And from here we got, from this ab, we get 8 over 3 minus 3b equal negative 5. So we are having 3b is 5, okay, 5 plus 8 over 3. So 3b is 15 plus 8 is 23 over 3. So b is 23 over 9. Okay. And from the c, we got 4 equal 3e. E is 2c minus 3e, or negative 4, sorry, negative 4 over 3. Okay. So we get a, we got b, we got c, we got e. Or do we have d? Oh, I think we skipped d. Okay, that's okay. Now yp is negative 4 over 3x plus 2 over 3, 23 over 9 minus 2x e to x minus 4 over 3 e to x. Okay, but it's still yp. Okay, it's still yp. This is still yp. It's a particular solution for non-homogeneous. Okay, the solutions. Okay, Uh, the general solutions then is yc plus yp, right? So y equal, the homogeneous one will be, let me write c1e, which one is we are using? C1e 3x, right? E 3x plus C2e negative x, okay? And then minus 4 over 3x plus 23 over 9 minus 2x e to x minus 4 over 3 e to x. Okay. If you want to verify whether this is correct or no, we can verify. So this is general solution. So verify or verifications. How to verify? We can check the yp1, that is ax plus b. Sorry. We can check and substitute to y prime minus 2y prime. Should be getting this result. Okay, and we can check the other particular solutions, which is the e. We can check through the other part. Okay. Okay. So what this is going to tell you is the non-homogeneous can have two different type of equation. It can have like polynomials and maybe trigonometric, or polynomials and then the exponent. And you may have the superposition principles to write the particular solution. Okay. So before it's going to be messy, maybe if you have any questions, you can ask first. I think I accidentally skipped the trigonometry. Let me go back to trigonometry to give you some example how to work with, and then at the end I will give you the table that hopefully give you idea for particular solutions, how to guess, okay, how to take guesses and then check and verify. Okay, let me go through how to use the undetermined coefficient for trigonometry. Okay, so let's say we need to solve y double prime minus y prime plus y equal to sine 3x. Okay. Remember, since this is differential equations, the one that might have if we are having sine or cosine, if we look at sine 3x itself, if we try to take derivative, we are going to have 3 and then cos 3x, right? And then if you successfully derive all the time, you will see sine, cosine, right? So the gases, okay, what we are going to check, okay, for the gas is probably it will be going to have two components. You need to have these two components. Okay, let's say we're just going to just observe this particular solution. Of course, the general solutions will be the step one is finding the homogeneous one, right? We take this homogeneous, okay, we take homogeneous, solve homogeneous, and then write your later general solution. But let's just skip to the particular solutions, okay? So let yp is a cosine 3x plus b sine 3x. Okay, now let's try to derive and twice. We derive twice. Sine, sorry. And then second one. Oh wait, this is sine, sorry. Sine. So we are going to have IP double prime going to have y prime and then minus. We are going to have 9a for cos 3x, and we are going to have let's say plus negative 9b plus 3a sine 3x. Is my maybe correct? Let me write maybe or maybe let's just write all and to see whether we can cancel. So let me just take negative. So this will be positive. This will be negative. Okay, and then plus. Okay, I think better. So 9a plus a becomes negative 8a. So negative 8a cos 3x. Cos 3x is negative 3b cos 3x, right? Plus, okay, um, negative 9b plus b negative 8b, so 3a negative 8b, right? And sine 3x. This is the yp double prime minus yp prime plus yp. Okay, I think okay, right? And this is equal to, let me write a little bit to the left. This is equal to, the equation itself is 2 sine 3x. So 2 sine 3x, okay? Now, how do we solve this? We just take groupings. Grouping this sine 3x. Which one? This one, right? So 3a minus 8b is 2. And what about the other one? The other one will be 0. So negative 8a, negative 3b is 0. Okay? So we may multiply with 8, multiply with 3 to give you 24a, 64b, 16, negative 24a, negative 9b, 0. And then plus, this is going to be negative 73b equals 16. b is negative 16 over 73. Not really a good number, but I just try to solve. So 3a minus, or maybe let me write it, 8a minus 3, so plus 4873 equals 0. So 4873 is 8a, so a is 6 over 73. So yp is 6 over 73 cos 3x plus or minus, in this case, 16 over 73 sine 3x. Okay. Okay. Okay, we'll just observe this yp. Okay. But the general solutions, you need to plus the homogeneous solution. Okay. Okay, maybe any questions first? Any question? Okay. Any question? We will have maybe 5 minute breaks. 5 minute breaks. Okay. Uh, Continue a little bit. Okay. All right. Let me give you the idea. Okay, what we have here. So this is some particular solutions that might have been our YP. So the left part is the non-homogeneous part in the equations, the right side. Okay, so when you have a constant, the form of the particular solution is just one, so it's just A. And if it is linear, it's x plus b, and you can see the form, etc. We have polynomial, we have sine, cosine. It's the same, both the same. When we have exponent, we already discussed, I think, the very start of the sections. We have the exponent, and if you combination between linear and exponent, you have linear multiplying the exponent itself. When you have the polynomials degree uh, greater than 1, we also have the same forms. Okay, and when you combine with sine, you also see that we need to combine both. For example, the e3x, it need to be combined with a cos 4x, b sin 4x, and then multiply. Okay, and then the other part, for example, the 11 and 12, we combine this polynomial with the trigonometric, right? So the polynomials, this is the polynomial, this is the polynomial. But remember, the sine or cosine will always be two components, sine and cosine. So we need to also include cosine and sine. Okay, but this is important to notice. Okay, so you don't have, you need to be aware of this, all of these combinations. It's not necessary to memorize all. Okay, not necessarily, but you need to know what may happen if you combine some certain function. So the one that you need to take care of is the exponent, the polynomials, and the trigonometry. Okay. Okay, that's this particular solution. Uh, One more thing regarding this uh, form of solutions that you may have is, remember that you can't write duplicity. Okay. Okay. Now, let's say we have a questions or differential equations. Let's say solve. The first one is y double prime minus 8y prime plus 25y equal 5x cubed e with power of negative x minus 7 e with power of negative x. Okay. Okay, if we write this e negative x and 5x cubed, we can write and becomes this, similar to this one, right? It has polynomial, it has e, so e and polynomial. So probably our choice for our YP, okay, is the polynomials that we have. It's degree 3, so we have 3. Oh, we usually avoid D because the letter D might confuse with differential. The differential operators we write also with D, so we can avoid that. So ax cubed plus bx squared plus cx plus e, and then multiply with e with power of negative x. Probably this is our particular solution. And I think you need to make sure there is no duplication between any terms in yp and the terms in the homogeneous. So the homogeneous one, we check, we need to write, so we can check using the constant and make it to black. I think this will be not complete roots, right? So we need to use the quadratic formula or complete standard form. So we can write this is plus 16 plus 9 minus plus 9, right? So m minus 4 plus 9. So m minus 4, m minus 4 is square root of 9i, or this will be 3i, right? 3i. So m is plus minus 4 plus minus 3i. And some sort of solutions for the homogeneous using the Euler alpha. This is beta, so this will be equal to e with power of 4x, right? And then this will be c1 cosine 3x plus c2 sine 3x. Okay. So notice that I think because the result is in terms of cos, sine, and e, if with power of 4x, there is no duplicity in terms of the types of the solutions that we might have. Okay, so I think this is still okay. This is just give you an example, okay, on how to look the solution. Now the next example, if we have um, y double prime plus 4y equal x cosine x. Okay. Now we have the polynomial and the trigonometry. It seems that we are going to have this, right? But in terms of polynomial, it is a linear. So we are going to have ax plus b, right? It seems that we are going to have ax plus b cosine x plus cx plus e for sine x. Okay. It seems that this is our particular solution. And of course, we are going to observe that we need to make sure that there is no duplications. So if we check the homogeneous one, so m1 and m2 is no alpha, alpha is 0, so we can write the yc is c1 cosine 2x plus c2 cosine 2x. So the rule, okay, basically what I want to say here is the rule. Okay, so assumption for yp consists of yp1, yp2 until some n. Okay. According to these relations, so the form yp is linear combination of all linearly independent functions that generated by repeated differentiations of g of x. Okay. Okay, let me give you more examples. Okay, how do we take care of our linear? Okay, okay, okay. If we have y double prime minus 9y prime plus 14y, let's say equal to 3x squared minus 5 sine 2x plus 8x e 6x. Okay. So when we are having this kind of structure, what we are going to do is we break down the non-homogeneousity. So we break down 1, 2, 3. Okay. Okay. So in the relations with the x squared, we will have our yp1. Let's say the first one is, because of this is degree of 2, we will have this is our particular solution for this case. Okay. The second one, sine 2x, we will have, let's say, e cos 2x plus f sine 2x, right? And then the other one here, the third one is x e 6x. And remember, when we have x and e together, then we will have also combination of, let's say, g x e 6x plus h e 6x. Okay. So you need to be careful on reading all these structures. Okay. Of course, the yp will be the sum of these three components. Okay. And of course, remember that you need to check duplicity. Okay. So check. Don't forget. Let me write. Don't forget to check homogeneous equations. Okay. Don't forget to check homogeneous equation for any duplication. If you have a duplication, then you need to rewrite another predictions. Maybe I can write some. Let me give you here, okay, some to notice. Okay, Okay. Okay, when we have a duplications, what we are going to do, okay, let me just go through here. So multiplication rule, actually I already give you what we are going to do. So we need to find any linear independent formula that can have relations and still can be plugged in. Okay. So let me just write the the official words. Okay, multiplication rule. If any yp contains terms that duplicate terms in yc, yp, then that yp must be multiplied by x with power of n. Depends on situation, where the n is the smallest integer, a positive integer that eliminates duplication. Usually it's happened with the exponent case. The exponent case. Another example is initial value. I think no need to be discussed. I think it's okay. So careful on duplications, okay? Maybe let me give you example for this multiplication for the non-homogeneous one. Let me just give you y double prime minus 6y prime plus 9y equals 6x squared plus 2 minus 12e with power of 3x. Okay. Okay, we can check first. Step 1, homogeneous equation. That is y double prime minus 6y prime plus 9y equal to 0. Okay? We could check the roots. I think this is so we have this, right? So m1 equal m2 is 3. Now the general solution for this homogeneous yc is, remember, c1 e 3x and plus c2, don't forget to write multiply with x for this multiplication rule. Okay. For the homogeneous. For non-homogeneous also the same. If you see the duplication. Okay. Now we are going to see the part here. Okay. So step 2, observe the g of x, okay, which means this is usually called g of x, the right side. So our predictions for the particular solutions, because it has the polynomial of degree 2, so we will have ax squared plus bx plus c, and then we have exponent that is we can write as e exponent 3x, okay. So yp1 here and yp2 is here. Okay, we have 2yp. Okay, now we see that this e is duplicating. Okay, so let me write here, and they give you warning, okay, duplications. Duplications, just write. Okay, so what we are going to do, we need to multiply. Okay, multiply with x. Okay, so try multiplying with x. So first, since one duplication happened, let me write here. The logic for the process, okay, then we try to first multiply with x, but still it duplicates the second one, right? Still duplicate. So we need to multiply again. Okay. So if we multiply with x squared, then finish. No duplications, right? So this eliminates duplications. So we choose this, okay, as our e. So our yp that is our yp. And how to solve? Similar what we have. We are going to differentiate twice, and going back to the equations, and then equaling left side with right side, and then we see collecting the terms, solving the linear equations, and we may have our general solution. Okay. So at least we have two cases. Okay, case when not non duplications. The second case is when duplicity happen, when duplication happen. Okay. And again, whenever you see duplication, and sometimes usually duplication happen when you have the exponent. Okay, because it's the exponent is the frequent function that has in DE. So when you have the exponent, you have duplication, just multiply with x. If you still have any other component that has same duplication, multiply again, x squared, x cubed, x to the fourth. Okay, depends on how many duplications you have. Okay. Okay, I think that's all for undetermined coefficients. Okay. Okay. I think for some parts, you can check, like for this one, you can check the general solution by yourself. Okay, you can check by some calculation. But let me, before we continue, I will just give you time for if you have any questions or maybe still have confusions on this undetermined coefficients. I hope, although we are having quite gap from the first order differential equation and then jump to higher order, and we see that we are really jump really high, right? I think the lessons in Monday class, I think it's jumping too high. But I hope by today's lecture from the morning and afternoon session, we see that actually we can make the examples and the definitions, all the theorem, more practical. Okay, because I think in higher order, because it's difficult to imagine some sort of any method that can happen. We usually using the same method as in the first order. Okay? Like we force to come out the like the reduction order. We force the equation to be a linear, right? And then the constant coefficient, we somehow analyze the differential equation through quadratic formula, right? Quadratic formula. Okay. And we have three different cases, right? We have the real roots, distinct. We have roots that has equal root value, and we have the complex conjugations, right? We have the imaginary number, right? And to link that imaginary number with the real coefficient, we need the Euler formulations. Although maybe you don't really understand what is the Euler, okay? You just use that for a while. That's just a tool. Maybe I will share one or two links that can be helpful to understand what is Euler formula, because it's connecting the imaginary or the complex plane with our real plane. Okay? So it's kind of it can transform the imaginary solutions and transforming into real functions. Okay. Okay, now the next method, we have the we call the variations of parameters. Okay. Variation parameters, usually it starts from when we have basic problems in undetermined coefficients. We may say, okay, it works really good, right? But sometimes when the equation's a little bit tough, we need more method to solve. Okay. Okay. Any questions so far? Do you think the morning sessions and now still okay with you? Still can understand? Okay, no question. Okay, but I think it's practical, right? When I give you example and you see some sort of how to solve, at least you get the idea of what kind of steps you need to make, the process, first, second, third, right? Okay. Okay, I think. Okay, no question. Okay. 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 Okay, let me continue. Okay, let me give you I think a brief intro. We still have time about 1 hour. So let me give you a brief intro on variation of parameters. This method is called variation of parameters. Variation of parameters. Okay. So the method of undetermined coefficients may work for many problems. Okay. But if we consider the tangent, okay? If we consider just sine or cosine, you can directly get the idea of sine, cosine. You will have immediately, you can propose your predictions that it can be based on sine plus cosine, right, with some constant, and you can propose that as your solution directly. But if you have tangent, if we imagine the tangent for a while, okay, if we imagine, consider just for a while, okay, consider Gaussian's tangent. If we want to derive, okay, we get secant squared, right? If we derive again, what we'll get? It becomes 2 secant and secant chain rule secant tangent. So 2 secant squared tangent x, right? If you try differentiate again, it becomes a product rule, right? Let's say the third derivative. It will be secant squared, or let me just write this. The tangent becomes secant squared, secant cubed, and then secant fourth. So we will have 4 secant squared x tangent x, right? And then plus the product rule. Secant squared is secant fourth, so 2 secant with power of 4, right? And if imagine you derive, it's getting massive, right? Now, to solve this, we can handle through variation of parameters, which in most cases we can handle anything that is having like any function we have. The equation form Ly, or let's say just L and Y, Ly equal f of x. Okay, let's try the formula. Okay, let's try the E tangent. Okay, using the tangent, we try to solve it. Okay, first, as usual, we try to find homogeneous. And perhaps we can get that this is C1y1 plus C2y2, right? The homogeneous always getting this C1y1, C2y2. And for some guesses, this might comes up as using the m squared plus 1 equals 0. So m is plus minus I, right? And using the Euler, you get the idea that this might have cos x, and sine x. Okay, alpha is 0, beta is 1. And now for yp, okay, to find yp, let's try yp equal to u1 y1 plus u2 y2. So we try this u. Okay, u is a function, not a constant. Okay. What we are going to do is we need to satisfy that ly tangent x. Okay. L is the differential operator. That gives us, we need to satisfy this. That gives us functions u1 and u2. And then compute. Okay, compute the y prime. We will have a product rule of two components u1 y1 and u2 y2. So we will have u1 prime y1 plus u1 y1 prime, right? And then plus u2 prime y2 plus u2 y2 prime. And let me write the u1 prime y1 with u2 prime y2, and then plus u1 y1 prime plus u2 y2 prime. Okay. Okay, we can still take one more condition, okay, to simplify our calculation. So we have two unknown functions, right? We have u1 and u2. Okay, so we need to take one more condition. So requires, okay, we need to requires that u1 prime y1 plus u2 prime y2 equals 0. Okay, when we take this 0, then our y prime becomes just u1 y1 prime plus u2 y2 prime. Okay, and then we take the second derivative, again the product rule, u1 prime y1 prime. Let me just make arrangement, okay, after product rule. So u2 prime y2 prime plus u1 y1 double prime plus u2 y2 double prime. Okay. Okay. Since let me write here. Since y1 and y2 are solutions of homogeneous one, then we find that y1 double prime is negative y1 and y2 double prime is negative y2. To make it 0, right? Okay, to make it 0. Okay, and then let me go through the next slide. If equation is y double prime plus bx y prime plus qx y, we could have can rearrange this, and it seems that we can have a connection with this linear. Okay. So our yp double prime okay. We can see that we can have this kind of structure, okay, from the, if this is our equations, okay, we can have this kind of structure, and we can have a groupings between the y prime and y, right? And then we know that u1 y1 plus u2 y2 is our y, okay? Now we can have this whole thing here, just y, okay? And then if we take the equations back, that y double prime plus y, this is supposed to equal with u1 prime y1 prime plus u2 prime y2 prime. And again, it fits with the equation from the beginning. Okay? This is just arranging the formulation. Okay? So what we need to solve, two equations on u1 and u2, which is, the first is u1 prime y1 plus u2 prime y2, this is equal 0, and second is u1 prime y1 prime plus u2 prime y2 prime is equal a function of x. So we solve the u1 prime, u2 prime in terms of f of x, y1 and y2. And we always get the formulas for any operation functions for f of x. But we need to remember that the operations for the calculations is, it need to be, we have this kind of structure that's similar to what we have in the linear one. Okay. Okay, now how do we using this formulation? Let me just write in the right side here our questions. That is y double prime plus y is tangent x, right? So first, from the homogeneous one, we know that this is c1 sine x, or Let me check whether we have write all the solutions. Yeah, C1 is cosine x, C2 sine x. Okay. And I think we can just say that this is sine and cosine x. Oh yeah, we could just say the C1 and C2 is just 1. So this is y1 and y2. Now we can write the u prime y1 plus u2 prime y2 is equal 0. So we can change this into cos x plus u2 prime sine x. But you need to be consistent for your writing. Which one is your y1, which one is your y2, okay? Because if you not consistent writing it, maybe the answer will be a little bit different, okay? But it's okay if you write A becomes B, B becomes A. At the end, you will find the same conclusion. Okay, find the same conclusion. Okay, now we differentiate the second one. We have the y1 prime. So y1. So this was y1, y2. So y1 prime is negative sine x. Y2 prime is cos x. So we need to include. So this is the first one. The second one is this one. So this is first, second. So we're writing. So this is negative u1 prime sine x plus u2 prime cosine x equal to the f of x is tangent x. So the goal is we set up u1 and u2, combining with the y1 and y2 that we came up with from the solutions, the homogeneous one. Okay. Okay. Now to simplify it, we can multiply this with sine. And then multiply this with cosine, okay, to remove the sine over cos become just sine. Okay, so this become u1 prime sine x cos x, okay, plus u2 prime sine squared x, and this one sine x cos x, okay, then plus u2 prime cosine squared x, and equal sine x. Okay. And finally, we will see that u2 prime, if we plus this, this will be sine x, and this will be canceling, right? So u2 prime is sine x, and u1 prime is, we can take the solutions. So sine cube, so negative sine squared x divided by cosine x, just substitute. So negative tangent x sine x. So integrate u2, integrate sine x, negative cos x, u1 integrate this negative tangent x sine x. You remember to integrate this. You can take times to integrate, but let me just give you the results. You can write half ln sine x minus 1 sine x plus 1. You can just use calculators if you want. And then plus sine x. Now particular solutions, yp is u1 y1 plus u2 y2. Don't forget that we still need to write with y1 and y2. Okay, so half sine x minus 1. It should be x is in the bracket. Okay. And multiply with cosine x plus cosine x sine x minus cosine x sine x. Or we could write it's cancelling. So it's half cosine x ln sine x minus 1 so the y, the general solution, is c1 cosine x plus c2 sine x plus half cosine x ln okay. Yeah, a little bit complex and complicated because you are going to have u as your multiplication for your particular solution. Okay, and there is no specific method. Okay. Okay. This is just one way to look at, but it's not the general form. It's just an example. Okay. We will have a more concise rule for this type of method. We are going to include the Wronskian. Okay, include the Wronskian. Okay, let me give you more in more concise and clear. Okay, this is just to give you the idea on what we could have. Okay. Okay. So idea is taking the particular solutions as some unique functions, okay, or we could say let's say it's u1x y1x plus u2x y2x. Okay. The idea is we are going to sub this substitute, and to sub this to solve the dy dx equal or plus p of x y equal function of x, and y1 and y2 are form of set fundamental set of solution. Okay, so it means that the homogeneous form. Okay, now the yp, if we differentiate 1, differentiate twice, okay, and then write down the formulations. Compute. Okay, and then plus the other part, so this will be 0, this also 0, so plus y1 prime u1 double prime plus u1 prime y1 prime plus y2 u2 prime plus u2 y2 prime prime. Okay, and then plus p y1 u1 prime plus y2 u2 prime plus y1 prime u1 prime plus y2 prime u2 prime. We can set up the product form from all the y1 u1 prime plus ddx y2 u2 prime. Okay, so we can make a more structure from here. Okay, so plus p plus y1 prime u1 prime plus y2 prime u2 prime. Okay. Yeah, make 2 ddx form. Okay. And then we can combine. Right, we can combine. And plus p and plus this part. So this and this and this. Okay. So what is our goal? We want to find u1 and u2. Okay. This is just to say that the y1 u1 prime plus y2 u2 prime so this is we demand that this one going to be 0. And then this will be equal to f of x. Okay. So, okay, maybe before we are going through a little bit, let me just give you the idea. Okay, so we are going to substitute this particular solutions. Okay, we're going to substitute to solve some certain of differential equations. Okay, let's say we are going to check this first derivative and second derivative and then substitute to the differential equation. Okay, so we check the two first derivatives, the second derivatives, and check through our equation. Okay, and after some parts, we know that this will be our homogeneous one, that is 0. Okay, and then we are having all this stuff here that we can make up our product form. Okay, product form, and becomes this. Okay, so we simplify all this stuff here, becomes our product form. Okay, now we have another form that is in P here. What we really care is we want to make this as our equation that equals 0. Okay, so that if we have this as f of x here, then we kind of figure out that because we have this in terms of differential, and this is the same thing as we have, okay, from this one. Oh, it's supposed to be y prime. Then we can solve the entire equation. Okay? So we are going to have two systems that has so y prime u1 prime plus y2 prime u2 prime. It is to be equal to the function of x. Okay, if you remember the Wronskian, okay, the Wronskian, so we are going to change into the matrix, the matrices. So the Wronskian, we remember the determinant y1, y2, this is y1 prime, y2 prime, right? Should be y prime like that. Okay, now if you remember the Cramer's rule, we will get to the matrix later on if we have time. We will have solutions. Okay, solutions. So let's say we are using the Cramer's rule. So the Cramer's rule say that we are going to substitute the first column with the 0 and f of x like that, the right side, and skip the right the same. And W2 is we substitute the y2 and y2 prime with the right side of equations, which is 0 and f of x. So by Cramer's rule, we will have that u1 prime is equal to w1 divided by w, which means the determinant, the Wronskian. The determinant of w1 divided by w. And u2 prime is w2 divided by w. So this is the same Wronskian that we have in the beginning of the higher order to check the linear dependency, right? If you want to make it linear independent, the Wronskian is not 0, right? Okay. And then you will have u1 and u2 by integrating this, okay, by integrating. Okay. Okay, and then what I want to suggest to for this method is it's not memorizing all these symbols, because the variation of parameters will be really messy. Okay, so the first thing that you need to recognize is first you need to utilize the Wronskian, the determinant. Okay. So I think one thing that you need to keep in mind is I think this one. And solve through the Wronskian, find the determinants, and find the, actually it's a Cramer's rule in matrix. So first we need to identify the homogeneous equation, homogeneous solution, and using the solution into our Wronskian. Okay, if you see from here, this y1 and y2, y1, y1, right? And we have y2, y2. Where does it come from? It's come from our homogeneous equation. After we solve the homogeneous one, we get a proposed solutions, that is y1, y2. We use that to analyze our Wronskian. Okay, let me give you some sort of demonstration on how we are going to solve this variation of parameters. Okay, I think since it's quite complicated, I will just review on Friday and having more, I think a few exercise, and I believe I can have exercise also from the previous one, the undetermined coefficient and the homogeneous constant coefficient. Okay. And maybe introductory a little bit on Laplace. Okay. Let me give you an example. space, let's say we have this DE. Okay. I think we can also solve this through the undetermined coefficient, right? No problem. But let's say we are going to use the variation of parameters. Right? So you can have a sense of priority, which method you are going to be applied. Okay, first is taking this m squared minus 4m plus 4. Let's solve this for homogeneous one. We say that we have this as our, so m1 is 2, m2 also 2, right? So we have equal roots, which means it's the second case, right? If we remember, then our, write it what? Our solutions for the homogeneous one will we have C1 e to x plus C2, don't forget x e to x, okay? Because we have an equal root. Okay. And then let's identify y1 as e to x and y2 is x e to x. Okay. We identified it. Compute our Wronskian using these two. So first derivative, but I think I need to take it a little bit right here because it has a product rule. So e to the 2x, so 2x e to x plus e to x. Okay. Now take the subtraction for this multiplication. So 2x e 4x plus e 4x minus 2x e 4x. So it will be e with power of 4x. Okay. Okay, and then we can identify this part as our f of x, right? Or we can write here, this is Wronskian. So f of x is x plus 1 e to the x. Okay, e to the 2x, right? We can set up the Wronskian again. Now exchange this to this will be to 0 and this is f of x, okay? And this is supposed to be y1, y2, right? Y2 or y2 prime, okay? So we set up this. So f of x, let me just write f of x is x plus 1 e to the 2x. This one is x e to x. And this is 2x e to x plus e to x. And this will be minus x plus 1 e for x. Oh, x, sorry. Forget x. Okay. And y2, w2, sorry. This is e to x, 2e to x, 0, x plus 1, e to x. Notice that it doesn't matter when you choose, for example, you switch this y1 and y2. the next Wronskian also switch, right? So it should be okay if you pick different y1 and y2. Okay. Okay, let's say this is x plus 1 e for x. Okay. And now from the w1 we have u1 prime is negative x plus 1 x e for x, defined by w is e for x. Okay, so we will have u1 prime is negative x squared minus x. The u2 prime is x plus 1 x e for x. This is, I think, easy example to just to see how it's work and what's the pattern and what you need to keep in mind for the Wronskian, right? And this will be x squared plus x. And then u1 is integrating all this stuff, and we are going to have negative 1 over 3 x cubed plus negative half x squared. Okay, no need to add constant now. u2 is x squared plus x dx. Oh, sorry. This is not x. Okay, so this should be just x plus 1. So x plus 1 dx. So having half x squared plus x. Okay. And then from this u1, u2, we have yp. Okay. Remember, we need to be a consistent. Okay. Which one is u1, which one is u2? It corresponds to what our proposal here. So y1 is, let me write here, y1 is e to x, y2 is x e to x. So yp is negative 1 over 3x cubed, negative half x squared, and then this will be corresponds uh, with the y1, right? y1 is e, and then plus the half x squared plus x correspond with the x e to x. And you may just solve it and make it 1 over 6. Okay. But remember, this is just the yp. The general solutions, we need to include homogeneous. Okay. So general solution. Yc plus yp. And plus this 1 over 6. Okay. Okay. I think for the method, because you were going to use the determinant of Wronskian, uh, if you look on the third order, you are going to find 3 by 3 matrix, right? So the Wronskian, the determinant is by 3 by 3. But I think for our class, we can just restrict our condition just 2 by 2 for variation of parameters. Okay, but it can happen for 3 by 3. But for our lesson, for our class, we just consider 2 by 2. Okay, for the matrix. Okay, any questions? Any questions? Any question? I think we can stop early, but I will want to give you another feedback if if, uh, if it's okay with you. I will just go through feedback. Let me check my feedback. Okay. All right, we can have. Okay. Okay. If you don't have any questions, then perhaps we can go for some feedback time. Okay, or if you have any questions, please uh, go to the chat box. Okay. I will give you a short summary for this one later on Friday. Okay. We will see some more practical exercise. Okay. Okay, if you don't have any questions, let me just stop this sharing screen and let me just go through my second screen. Okay. Okay. Okay, please join the feedback sessions. Okay. Let me wait for a while. So we will have skip some parts, okay, on the sections and chapters. We will skip most of the modelings, like physics modelings, chemistry, population, growth, something like that. I believe we don't really have much time for the summer course. Okay, I think we can start, right? Okay. I hope the time is okay. Uh, please use your student ID. Okay, student ID. Use your student ID so I can map your score to the system. Okay, let's say we are going to start now. Okay, okay, get ready. This is just a concept. Okay, just a concept where you still remember the concept. Okay, the concept. I think I just give you a few hints on today's course. Okay. I hope you still remember what kind of structure of general solution that we can have for this DE. Especially the last part, I give you what kind of solution and what it need to be related to y1 and y2. Okay, good. Yeah, I think the concept you got it. The concept you got it. Okay. Okay. Okay, number 2. Let's get ready. 3, 2, 1. Okay, true or false. Okay, if you remember the Wronskian that I tell you about in the last session, and I tell you this in the I think the Monday class, right? The Wronskian, we have the Wronskian. What kind of Wronskian do we need to make the functions linearly independent? It's true. It's true. So to be linearly independent, the Wronskian is not equal 0. Okay. Okay. Go for the last one. It is, has a little bit calculation, so if you want to prepare some piece of paper and pen, you can do so. Okay. So 3, 2, 1. Let's start. Around 3 minutes. Around 3 minutes. Okay. I hope enough. Okay. Remember, reduction of order. The first steps is to substitute. Use substitution. That includes y1, right? That includes y1. Or you can just write y2 equal y1 and have some integrations, right? And the inside integration, you need to use your integrating factors. Remember the integrating factors. You get the integrating factors, and you get the solutions. I think you can also figure these questions by looking at the forms. Looking at the forms. And try to make out whether it's verified the form is correct or no. It also can be true. around 20 seconds. Okay, good. I think easy to be verified, right? Just take different differentials twice, plugged into the equation, and you can verify it's true. Okay. Okay. Oh, okay. Now you are the winner. Okay. So congratulations. And as usual, please give me your feedback and write your student ID. Okay. If you don't have any feedback, just write your student ID. That's fine. I will prepare your quiz. So if it's prepared not tonight, I will send tonight. If not, then I will send tomorrow. Okay, tomorrow morning. Okay, tomorrow morning. Okay. So I think I will just stop until here because uh, I believe already heavy subject for today. So Friday class we will have some, I think, practice for the higher order differential equation, some questions, and then maybe a little bit introduction of Laplace transformations. Okay, if you don't have any questions, then we will stop until here. And let me stop the sharing. Yeah, Tina, you can ask which questions you have. Okay. Oh, I am scared. Who's scared? Yeah, please, if you have questions. Oh, you already checked? Oh, okay, okay. I have to check the model. Yeah, because I think the model one, the system has not have not set me as the instructor, so I need to check with the staff for the one that set up the model um, to verify whether when I can uh, set up the model. I think because last week they just update before the course itself is not in the Moodle, but now it's on the Moodle, the course. But my name is not the instructor. It's just just the course name. So I need to make sure again. So you will know the model is on when I maybe assign some homework or some attachment PDF files for you to check. Okay. If not, then they said that every Friday they will update. So maybe this Friday they will update. So hopefully they update this week. Okay. Okay. If there's no other questions, I think we can stop until here, and we will see you again in Friday class. Okay, we can have some review on this higher order differentials, and we can have a little bit introductions to Laplace. Okay. Yeah, you're welcome. Yeah, you're welcome, Gina. It's okay. Yeah, everyone, you're welcome. Okay, I will stop the recording.